Hello friends, welcome to the channel Btech. So KTU's 4th semester mathematics examination, that is MA202, probability distributions, transforms and numerical methods, is to be conducted on September 15th. Only few days left. So I thought of giving you a question paper discussion from the module Laplace Transforms. Okay, I think around 20 to 23 marks can be scored from this particular module. Also it is very easy. Only few sets of formula and theorems are there. Also, we will be directly moving on to the solution instead of giving you detailed descriptions on theorems, formula, etc. for the sake of time. Okay. So, let's start. Here comes your very first question. 5b. Find the Laplace transforms of the following: cos t minus t sin t. Okay, let us copy. Find the Laplace transform of cos t minus t sin t. And the second one is 4t e raised to minus 2t. Find the Laplace of 4t e raised to minus 2t. 5b1 and 5b2. Okay. So let's start doing Laplace of cos t minus t sin t. Okay, the formula behind is Laplace of cos at is s by s square plus a square, and Laplace of t raised to n f of t is minus 1 raised to n d by ds of Laplace of f of t. Okay. So first one, Laplace of cos at. What is that? Here a is equal to 1, isn't it? So Laplace of cos t is equal to simply s by s square plus 1, because a is 1 here. Cos t and cos at, a is 1 here. And next it is Laplace of t raised to n here is 1, isn't it? T raised to 1 sin t. So t raised to 1 sin t equal to negative 1 raised to 1 d by ds of Laplace of, what is f of t here? F of t means the function associated with t raised to n, that is along with t we have sin t. So f of t is our sin t, and negative d by ds of Laplace of sin t. Also we should know that Laplace of sin at is a by s square plus a square. So here Laplace of sin t is d by ds of 1 by s square plus 1. Okay, now we have to take the first derivative for 1 by s square plus 1. What is that? D by dx of 1 by x is negative 1 by x square. Okay, so here it becomes, don't forget to put this minus, and 1 by x, instead of x we have s square plus 1, isn't it? So negative 1 by, instead of x square you should write s square plus 1 whole square. But since we have s square plus 1 polynomial, let's take chain rule method, that is have to differentiate s square plus 1 along with it, that is 2s. Now it becomes minus of minuses plus, isn't it? So 2s by s square plus 1 the whole square. Okay, now combining, that is our answer, Laplace of cos t minus t sin t, isn't it? Laplace of cos t is s by s square plus 1, and negative t sin t has 2s divided by s square plus 1 whole square. So this becomes your answer. Okay, s by s square plus 1 minus 2s by s square plus 1. Moving on to the next. Next is Laplace of 4t e raised to minus 2t. See, if you have a combination of exponential and a function, that is e raised to at and f of t, then you have to move with frequency shifting theorem. It says that Laplace of e raised to at f of t is, for the time being you have to cover this e raised to at up, and what is Laplace of f of t? You have to write that first, Laplace of f of t. Now that we taken this Laplace, we will have the function in variable s. Now replace your s value with s minus a, and a comes from this coefficient of t. Okay, in the power you have at. So the coefficient or the term along with t must be reduced from s. Okay, so this is your frequency shifting theorem, and you can proceed this question like, you can see just your f of t is t, isn't it? T. 4 can be taken outside being a constant. So it becomes like 4 into Laplace of t e raised to minus 2t, and f of t is t and a is your negative 2. Okay. So applying this equation, Laplace of f of t. What is f of t? Our f of t is t. Okay. and take the Laplace, and we will get like t raised to n. Okay, Laplace of t raised to n is n factorial by s raised to n plus 1. So Laplace of t raised to 1 is 1 factorial is 1 itself, 1 factorial by s raised to 1 plus 1 is 2. Okay, so your answer is 1 by s square. Later the solution is not yet ready. Now you have to replace this s with s minus, what is our a? A is negative 2. So your answer is 1 by s minus of minus is plus. So s plus 2 the whole square. This is your answer. Okay, oh, forgot to put this 4. So these are all the careless mistakes you can expect. Okay, 4 by s plus 2 the whole square is your answer. Now let's take the second question. 6a, find the inverse Laplace of these two questions. Let us copy. Inverse Laplace of 2s plus 1 by s square plus 2s plus 5. See, if you have a polynomial like this, you have to modify the question. Okay, this sixth one, 6-1. Okay, you have to modify the denominator now. I will give you a formula like s square plus as plus b. If you get such kind of polynomial, you have to modify it into s plus a by 2. What is a here? It is coefficient of s. So s plus a by 2 the whole square minus a by 2 the whole square plus b. Okay, if you have like s square minus ab, or sorry, s square minus as plus b, then you have to go like s minus a by 2 the whole square, again minus a by 2 whole square plus b. The sign does not vary. Okay, so this is the basic rule to modify such kind of polynomial. So in this question we can rewrite the denominator like L inverse of 2s plus 1 divided by s square plus 2s plus 5. We can make use of this equation. It is like s plus 1 whole square minus 1 square plus 5, isn't it? Now it is like L inverse of 2s plus 1 divided by s plus 1 whole square plus 4. 4 can be written as 2 square. Okay, because we have the cos 80 and sin 80 Laplace like s by s square plus a square or a by s square plus a square. So that is why I wrote 4 like 2 square. Okay, now you can observe that here a group is there, s plus 1. Okay, but we lack such a group in the numerator. So we have to get such a group s plus 1 in the numerator section too. How to get that? L inverse of, see, this 2s plus 1 can be written like 2s plus 2 minus 1. I splitted this 1 like 2 minus 1 divided by s plus 1 whole square plus 2 square. Why? Because here you can see that 2 can be taken outside, right? So inside we will have s plus 1. Thus we have a group there, s plus 1 minus 1 divided by s plus 1 whole square plus 2 square. Now that you have got the group in both numerator and denominator, replace this s plus 1 to a small letter s. Okay, so what happens is L inverse of 2s minus 1 by s square plus 2 square. Now again I can write like L inverse of 2s by s square plus 2 square minus L inverse of 1 by s square plus 2 square. Now it becomes s by s square plus 2 square. 2 can be taken outside. Now it is the inverse is L inverse of s by s square plus 2 square is cos 2t, isn't it? L inverse of s by s square plus a square is cos at, and L inverse of a by s square plus a square is sin at. Or again another formula, L inverse of 1 by s square plus a square is 1 by a sin at. Okay, minus, here you can see 1 by s square plus a square. It is like 1 by 2 sin 2t. See, still the answer is not yet complete because we had a replacement like s plus 1 to s. See, in frequency shifting theorem, we had like, if there is a combination of e raised to at and f of t, we had a replacement. In inverse Laplace transform, if we have a replacement, we have to accompany one e raised to at with f of t. Okay, Here we have a replacement like s plus, wait a second, we had a replacement like s plus 1 is replaced to s, isn't it? So it is like s minus a is replaced to s, which means our a here is negative 1. So what you have to do is, you have to join one e raised to at or e raised to negative 1t along with your f of t. Thus you get the solution like e raised to minus t 2 cos 2t minus half sin 2t. Got it? Next question. Find the inverse Laplace of 2s minus 10 by s cube e raised to minus 5s. Let us copy. So you have to find the inverse Laplace of this particular function, and you can see here exponential is combined with the function, but the function is in s terms, isn't it? This is a Laplace function. So you have to go for time shifting property, like Laplace of f of t minus t0 is equal to e raised to minus st0 Laplace of f of t. Okay, here the Laplace of f of t means definitely here we have s variable function. Also here also we have an s variable function. Also e raised to minus 5s along with this function, similar to here e raised to minus st0 along with this function. So by comparing we can just have like t0 is your 5. Okay, t0 equal to your 5. Now what is f of t then? What is f of t? F of t, see, combining this and this, you can have like L of f of t, not f of t, L of f of t is 2s minus 10 divided by s cube. Okay, let us split like 2s by s cube minus 10 by s cube, that is 2 by s square minus 10 by s cube. This is your L of f of t. What about the f of t? Just need to take the inverse of this. You have another formula like L inverse of 1 by s raised to n is equal to t raised to n minus 1 by n minus 1 factorial. So 2 by s square means 2 into n minus 1. N here is 2, right? So n minus 1, 2 minus 1 is 1. 1 factorial is simply 1 itself. So t raised to 1 divided by n minus 1 again. 2 minus 1 factorial is 1 factorial. Minus 10 into here 1 by s cube. So cube means n is here 3, right? So t raised to 3 minus 1, that is t square divided by 2 factorial. 3 minus 1 factorial is 2 factorial. So your answer is like 2t minus 10t square by 2 or 2t minus 5t square is your f of t. Okay. But according to the time shifting property, if your function is like, your Laplace function is like e raised to minus st0 L of f of t, then your inverse Laplace is f of t minus t0. So here your Laplace equation is Laplace of one function into e raised to minus st0. So what is your expected function? The real Laplace, inverse Laplace is, so it is simply f of t minus t0, and here you have your f of t. So in order to get your f of t minus t0, or your t0 value is 5, right? So to get your f of t minus 5, just replace your t with t minus 5. Your answer is then 2 into t minus 5 minus 5 of t minus 5 the whole square. This is your answer. Got it? Now the last question. See 6b. Solve y double dash plus 2y dash plus 5y equal to 25t. This is a differential equation, and this is a very sure definite question, 100% sure question from the chapter Laplace Transform. Okay, let us copy this. To do this kind of question, you need to know Laplace of y double dash of t is equal to s square Laplace of y of t minus s y of 0 minus y dash 0. Okay. Also Laplace of y dash of t, first derivative, it is s of L y of t minus y of 0. Okay. That is the first term. See here you can say column wise it is going to be the same only. And you can even write like, what is Laplace of y triple dash of t? This is s cube into L of y of t minus s square y of 0 minus s y dash 0 minus y double dash 0. So here you can identify one pattern. Anyway, this is the maximum derivative, like you need not want to study Laplace of fourth derivative and all. This 3 is enough. So for our question y double dash t, see how to begin this answering is, we have to take Laplace for both LHS and RHS. That is Laplace of y double dash plus 2y dash plus 5y is equal to Laplace of 25t. This is how you begin such kind of differential equation questions solved using Laplace transform. Okay. Now individually give Laplace transform to each term. That is Laplace of y double dash plus Laplace of 2y dash plus Laplace of 5y equal to Laplace of 25t. Substitute your equation. Laplace of 5 double dashes, take this one, s square L of y of t minus s y of 0 minus y dash 0 plus, put a big summation sign, okay, to identify the terms separation, and Laplace of 2y dash, take this 2 outside, now open a bracket because 2 is common to this Laplace of y dash. Okay, now take this formula, Laplace of y dash t is s L of y of t minus y of 0. Okay, go for a bigger summation sign, take this 5 outside, now you will have like Laplace of y of t equal to RHS Laplace of 25t, 25 into Laplace of t is 1 by s square. Okay. Now you have to substitute this y dash 0 and y of 0. It is given in your question itself. Both are negative 2. Substitute those values. See, I have substituted this negative 2 values for both y of 0 and y dash 0. Let us reduce this even more. Like, see, you can see that L of y of t is coming in some terms. Let us choose them, this term here and here. So let us open a bracket. You can take s square, then 2s, 2 into s. Okay, please consider this 2 also. So 2s and plus 5. Later you can pick up this 2s s terms. Okay, that is 2s, and that's all. So plus 2s, and next you can choose the constant terms. That is, you have 2 here and 2 into 2 4. So 2 plus 2 into 4, 2 plus 4 is equal to 25 by s square. Thus you have like L of y of t is s square plus 2s plus 5 plus 2s plus 6 is equal to 25 by s square. Now you have to derive it for L of y of t. That is, take every LHS terms to right hand side and divide it with s square plus 2s plus 5. Okay, next is you have to take the inverse Laplace on both the sides. Once you take that inverse Laplace, you will arrive at simple y of t in your LHS, and that will be your answer. Okay, but before doing that, you have to modify this denominator because it is having such kind of polynomial which I mentioned earlier. So it is like numerator stays the same. Okay, 25 by s square minus 2s minus 6 divided by, what is that, s plus a by 2 the whole square, means 2 by 2 the whole square, that is s plus 1 whole square minus 1 square plus 5, or it is like 25 by s square minus 2s minus 6 divided by s plus 1 the whole square minus 1 plus 5 is 4. I think it is the same polynomial which we had earlier, right? This is your L of y of t. Now again you can identify one group coming here, right? S plus 1 the whole square plus 2 square. Okay, so what you need to do is you just replace s plus 1 with s. Okay, so if such is the, or let us take a capital letter s. Okay, so then you can say that small letter s will be capital S minus 1. Okay, So you have like 25 by, here you have small letter s. Small letter s is capital S minus 1. So it is like s minus 1 whole square minus 2 into again a small letter s, that is capital S minus 1 minus 6 whole division. S plus 1 is capital S, that is capital S square plus 2 square. Here comes your L of y of t. Give this denominator individually for each term, that is 25 by s minus 1 whole square into capital S square plus 2 square minus 2 of s minus 1 by s square plus 2 square minus 6 divided by s square plus 2 square. Okay. So till this step it is quite easy for you. Now you have to use partial fraction. See, there are three types of partial fractions. Partial fraction type 1 is, you will have a numerator divided by, denominator will be like a product of two polynomials, and the polynomials will be of the order s plus a and s plus b. Like you will have the power of s to be 1 only, and here this kind of fraction can be partially splitted up like a by s plus 1, s plus a plus b by s plus b. Okay, later on what you need to do is you have to multiply, okay, multiply both sides, multiply LHS and RHS by the denominator of your LHS. That is, here in this case numerator is multiplied with the denominator of the LHS, which means we will be left with only numerator itself. Now a by s plus a, multiply the RHS by the denominator of LHS, multiply this term with the denominator of LHS. So you will have like s plus a into s plus b coming over here. So s plus a and s plus a gets cancelled and you will be left with, see, s plus a and s plus b, isn't it? Now we can cut off these two and you will be left with s plus b alone. Similarly to the next term, s plus b, b by s plus b into s plus a into s plus b. So s plus b gets cancelled and we will be left with b into s plus a. So you can have like numerator equal to a into s plus b plus b into s plus a. Okay. Now by trial and error method, that is substituting different values for s, you can derive or you can find out a and b. Okay. And the second type of partial fraction is numerator divided by the product will be having, any one of the product will be having a power term 2, square term. Okay. So it is like s plus a into s plus b whole square. You can have this square in here, this first term, first product or second product. Anyway, this is like, for this s plus a you will have a by s plus a, and for the next denominator s plus b the whole square, you should have like b divided by s plus b plus c divided by s plus b whole square. So for the term which is having a power 2, then you have to split it like two terms, that is b by s plus b and c by s plus b whole square. If the power is 3, then you have to have like b by s plus b, c by s plus b whole square and d by s plus b whole cube. That is, by step we have to reach till this power. Okay. And again multiply LHS and RHS, same step as previous, with the denominator of your LHS. Okay. So in the LHS, when multiplied with the denominator, you will be left with only numerator is equal to, see, numerator can be any polynomial. Okay, is equal to a divided by s plus a into s plus a, s plus b the whole square plus b divided by s plus b, s plus a, s plus b whole square. That is, for each term we are multiplying the denominator of LHS. Now cancelling, you can have like numerator is equal to a into s plus b whole square plus b into s plus a into s plus b plus c into s plus a. Okay. This is your second type of partial fraction, and last type of partial fraction is numerator divided by, here the product inside the bracket you will have second degree polynomial. That is, for this second degree polynomial, your numerator for the partial fraction will be as plus b divided by s square plus a. Plus for this particular fraction, I mean this product, you can have like c by s plus b itself as in the previous sections. Now again multiply the denominator of LHS with to both the sides. Then you will have like nm is equal to as plus b into s plus b plus c into s square plus a, similar to the previous steps. Okay. Now let us check what is happening for our question. See, just check this thing. Here we need to make use of both section partial fraction section number 2 and section number 3. Type 2 and type 3 is coming together here. Okay. Let us take this separately. So type 2 and type 3 is coming here. For this s minus 1 whole square, we can have like a by s minus 1 plus b by s minus 1 whole square, because stepwise we are getting into this power 2. And later on for s square plus 4, we can have like here this is second order term. So it is like cs plus d divided by s square plus 2 square. Okay. Now multiply the denominator of LHS to both sides. It is like, so here is your next step, and now you have to take different values for s. That is, when I put s is equal to 1, this term cancels off because 1 minus 1 is 0. Also this term gets cancelled off. So you will be left with 25 is equal to b into s square is 1. 1 plus 4 is 5. So it is 5b. So b value is simply 5. Okay. Now you have to substitute one value for s, for which two of the terms gets cancelled off. That is the procedure actually. See here, why did we choose s equal to 1? Because if we choose like that, then you can see that first term and second term gets cancelled off and you will be left with only the term containing b, thus b is solved. But I think there is no any other value available for us. So let us compare the terms, compare the coefficients. That is, here in the first term you can have the highest power to be the s cube, isn't it? So the coefficient of s cube is a. So we are going to compare the s cube coefficients. The coefficients of s cube in the first term is a. Now the coefficient of s cube in the second term, there is no s cube coefficient. So please leave it. Now what is the coefficient of s cube in this third term? You can have like s square is coming over here, also cs is there. So cs into s square is cs cube. So coefficient of s cube is simply c. So a plus c is equal to, what is the coefficient of s cube in the LHS? There is no coefficients, which means it is like 0 s cube. So just substitute a plus c is equal to 0, like then you can have like c is equal to negative. Okay. Now you can substitute s is equal to 0. Let's see what happens then. See, when s is equal to 0, 25 is equal to 0 minus 1 is negative 1. Negative 1 into a is negative a into 4 plus 4 into b is 4 into 5, which is 20, plus c into 0, 0, d into negative 1 the whole square, which means simply d itself, isn't it? D into 1 is d itself. So it is like 25 minus 20 is 5 is equal to d minus 4a. Now let's put another value for s, which is negative 1. See, it is your wish to compare the coefficients and get an equation or put different values for s. So it is your choice only. So when it is s is equal to negative 1, you can have like 25 is equal to negative 1 minus 1 is negative 2a, negative 1 whole square plus 4 is 5, plus 5b, plus c into negative 1 is negative c. So d minus c into negative 1 whole square is negative 2 the whole square, which is 4. Thus reducing, I get like 10a equal to 4 of d plus a. Okay. and you have the other equation d minus 4a is equal to 5. So 2 equations, 2 unknowns, solve the value for d and a. So these are the values for a, b, c and d. You can take a look for the steps. Now substitute these a, b, c, d to our partial fraction set. So our fraction 25 by s minus 1 whole square into s square plus 4 has now splitted into 3 terms like this. Okay, now paste these 3 terms into our previous main equation, that is here to here. Over here you can paste this, then it will be like, see, I have substituted that partial fraction answer over here. Now reduce it like minus 2 by s minus 1 plus 5 by s minus 1 whole square plus here you have 2s divided by s square plus 2 square, and split this negative 3 divided by s square plus 2 square minus again split this. See, you can split the numerators for these corresponding denominator, right? So it is like negative 2s by s square plus 2 square. Negative 2 into negative 1 is positive 2 by s square plus 2 square minus 6 by s square plus 2 square. You can see many similar terms coming up. See, now the equation is simplified to 3 terms. So this becomes your L of y of t, okay. Now please take the inverse Laplace individually for these terms. That is, y of t becomes inverse Laplace of minus 2 by s minus 1. Here you have a formula like L inverse of 1 by s minus a is equal to e raised to at, and here our a is equal to 1. So the answer is minus 2 e raised to t, 1t, okay, plus 5 by s minus 1 whole square. Here you have identified one group coming here, right, s minus 1. So what to do? Substitute s minus 1 with s. Then you will have like 5 by s square, and L inverse of 5 by s square is 5 into t. Since we have a replacement occurring here, multiply it with e raised to 1t. Okay, if the replacement is s minus 2, then you have to multiply e raised to 2t. Okay, so the second term inverse Laplace is plus 5 by s minus 1 whole square as 5t e raised to t. Now minus 7 by s square plus 4 is like minus 7 divided by 2 into sine 2t. Okay, here is your answer, but still it is not yet complete because we had a replacement like small letter s plus 1 was substituted with capital letter S. So what you have to do? Just multiply the whole of the function with e raised to negative 1t. So this becomes your final answer. Okay, this is your final answer. So I hope this video will be helpful for you to some extent at least. And to get the complete list of formula and theorems, please do join in my Telegram channel. You can get all formula and theorems concerned with this module in the Telegram channel. The link is given in the description box. So if you like the session, please do like, share and subscribe the video. Post doubts in the comment box also. So thank you and take care.